So let's see the concrete examples that we're going to use. The first one, semantic similarity. Our product person was kind enough to show us a few examples of expected output. So here's an example. You don't need to read through it. What we need to understand is that it represents the JSON schema that we expect with two keys, an answer and analysis, and an example on how we expect responses to come back. The friendly app master bot greets the user, provides the context, and even as part of the analysis, it returns us the documents it used to provide the answer. This was one of the requirements from the software engineer that is responsible for the RAG system. He wants to use this as a debugging mechanism, so we will verify that it exists. And we can compare the expected output we got to the actual one in the experiment that we ran. What's wrong with this picture? You're not supposed to be able to read all of it because there's a lot of text here. And if I need to read it, I need my glasses. But that's where semantic similarity comes into play. We got a score, a very high one. So when we go to customers these days, we still see many places where people have to go and read long lines of text and compare them. It's not scalable. If you implement any kind of system that will give you a semantic similarity, you will know where to look. So go and look for the ones that are lower than 90 if you want to see where you need to improve. The response format eval. So we mentioned we are expected to return a very specific JSON schema. Here we don't need a model. We can run a simple regular expression, which will check for the structure of the JSON with the keys that we want. And by the way, I said here we don't need a model. I lied a bit. Why? Because I didn't create this regular expression. I asked the model to create it. But it will run in a deterministic code. So it will be very cheap to run, and we can run it multiple times. Let's see some LLM-based evals. So I mentioned that we want the bot to be polite. So here I'm defining a custom LLM with a very simple question. Does the response answer the user question in a polite manner that mentions the friendly app master bot? And we will have a third-party model. By the way, it doesn't have to be a third-party model. You can actually use the same model for your prompts and for your evals, as long as it's in a separate process, okay? It has to be in a different context. But in this case, it will actually be a separate model that we fine-tuned a bit to answer eval questions. And okay, so we defined those evals. What are we going to do with them? Are we going to run them once on the single chat interactions that I did in the UI? Probably not. As Maxi mentioned, this is a non-deterministic system that in order to test it and to gain confidence and to gain statistical significance, we need to run multiple times in multiple iterations. And the way to do that is to take our prompt and to transform it into a template, if it's not already is a template, and to inject custom data as part of the experiment to that prompt, which we'll use the evals to run against. So we need a data set. And Maxim also mentioned it, and I will repeat it because this is probably one of the most important things in the eval world. We need to have diverse input that, by the way, unlike traditional software, where we had a few unit tests with a very simple input and output, here, since we don't know what to expect, we need the input to be very diverse. On one hand, it must represent real-world use cases, but also edge cases, and also unexpected terms, because you want to see how your bot will behave when someone will try to jailbreak it. Two good sources for various data sets for malicious content, for example, or jailbreak, Hugging Face and Kaggle. They are free, very recommended. Clear expected outputs. I know it's not trivial, and actually for some of the evals, we don't know it. We don't need expected outputs, right? To check if the bot answered in a polite way, we don't need an expected output, but for similarity, it's a must. So if you want to compare against an expected result, you better have one. So let's put it all together to a test. So I will not take you through all the iterations I did. Let's start with somewhere in the middle. This is V6 of my prompt. Let's expand it a bit. As you can see, I enhanced a bit, not too much, the system messages. It has an instruction to greet the user, to return JSON format, the RAG system that I have here. And let's take a look at the data set that I've just used. So this is my golden data set. I actually got it from the product guy that defined the requirement for this bot. And what it includes, various examples for user questions. Here's the known, I'm getting error 403.1. The documents that were fetched as part of the context by the RAG system. The RAG system is not part of your prompting. It's a different system. And in this experiment, we are assuming that we already have the documents. And the ideal answer for each of them. So I went ahead and I ran this experiment against GPT-4o Mini because, as you remember, I was asked to make it cheap and fast. And let's take a look at the results that I got. So semantic similarity is very high. I can go and drill down into each specific line, but we're probably good here. Let's see what the evals returned. Oh, here we're not in a great place. JSON schema only 25% returned the right schema. With the politeness, we are so and so, and the greeting, which is a very simple eval. It checks if the message begins with hi and the username. Also, we didn't get such a great results. So as Maxim said, we need to iterate. What I did first is to iterate with a different model. Sometimes a different model will give you better results. So here I ran the same experiment, only this time I choose Claude. Let's compare the two and see if we got any better. So this is the first one with GPT-4o Mini. And not surprisingly, Claude got almost a perfect score on the same instructions. Okay, I didn't change the prompt. We can see the prompts here. They are identical in both experiments. I simply used a much more expensive model. How much expensive? About 100 times more expensive. I cannot do that. When I went to my product person and I told them, hey, I got a solution, he said, no, you need to do a better job. So I went back to the drawing board. And this was already version, let's see. Version 8 of my prompt. Let's see what I changed here. We'll apply it. Okay, so a bit of prompt engineering. First of all, I gave an example. That example does not serve the actual content. It's meaningless from the model perspective, as the context here will not be relevant to many other questions, but it teaches the model to answer in the right format, in the right JSON format. I also specified again that it needs to be a JSON with 2 keys. I asked to always begin with hi and username as a parameter for the model. And I also asked it to mention that he is a friendly app support bot. And I did very minor changes in the initial instructions. And let's see how we did, again, with GPT-4o Mini, because the entire idea was to get similar results in a much cheaper manner. So we'll compare the first one that was quite bad. On average, about 50% of the evals worked. And the last one. So as you can see, we actually got very similar results to what we have with Claude, with a much cheaper model and actually much faster model. On average, we went down from, we went down from 10 seconds to 2 seconds. And that's the way you iterate and you test and you measure with evals. So we went through the data set that I've used, the evals that we've just mentioned. And that concludes my demo. Feel free to follow us on LinkedIn. If you have any questions after the session, of course, you are more than welcome to contact me either email or LinkedIn. And if you want to play with the system that I've just demoed, then in this link, we've just opened up free public beta access. Feel free to join us. Any questions? After the session, I don't have time. Okay. Thank you very much. And Ben.